what is the distance to be measured. Based on that you can take. Okay. Yeah, so plane scale, so we discussed in the last class. So before starting plane scale you have to know the LOS length. LOS you have to calculate. This LOS you have to divide into equal number of main divisions. So suppose if you take your normal 15 centimeter scale, if you take your normal 15 centimeter scale, can you tell me what is the main division of the this normal scale? Anyone? What is the main division and subdivision in this 15 centimeter scale? Anyone? What is the main division? Yeah. So in this 15 centimeter scale, the main division is centimeter. And what is the subdivision on this scale? What is the subdivision? Centimeter is divided into which units? Yeah, anyone? Millimeter. Okay. So whatever the scale you take, in the plane scale, you can take two consecutive units. One is here in this scale we are taking centimeter and millimeter. In the other scale you can take feet and inches. So the main division will be feet and your subdivision will be inches. So like that, any scale you have to create. It represents two subsequent units or units and its fraction. Okay. So examples such as meter and decimeter. Meter and decimeter you can take. Kilometer and hectometer you have to take. Feet and inches, millimeter and 1/10 of millimeter you can take. So generally any plane scale you have one main division and one subdivision. Those should be two consecutive units. Two consecutive units you have to take, such as meter and decimeter. Below meter you can find decimeter, and below kilometer you can find hectometer. So below feet you can find inches. Feet are divided into inches, then millimeters are divided into 1/10 of millimeter. So like this you can make the divisions. And so this is a plane scale. So if you look at your plane scale, if you look at your this normal scale, if I want to measure 10.2 centimeter, so I can mark here as my 10.2 centimeter. So how I divide is, from here I'll be taking 10 mm, 10 centimeters, and from here I'll be taking 2 mm. Then total will become 10 centimeter plus 2 mm, total will become 10.2 centimeters. In order to make 10.2, then I need to divide this 10 to 11. Suppose this is my distance 10 to 11. I have to make the 10 divisions inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have to make the 10 divisions. Then only I can mark 10.2. Suppose if I want to mark 12.5, then between 12 and 13, I have to mark 10 divisions. Again, I have to mark 10 divisions. Then fifth one, I can make it as this one. So what our engineers have done in the engine drawing, what they have done is, instead of dividing between 1 to 2, 2 to 3, 3 to 4, 4 to 5, it's a time taking process. If you are creating a new scale, because we have very less time in the drawing class and in the exam, we have very less time to do. So what we have done is, instead of dividing between 1 to 2, 3 to 4, 5 to 6, 7 to 8, so instead of dividing, what we do is we make the divisions. We make this division of main division only at the first. Between 0 to 1 only we make the division, and here we take only the main division. We only divide 1, 2, 3, 4, 5, 6 only. We don't divide between 4 to 5, because if I want to divide 4 to 5, I have to divide 10 equal parts. Then here also I have to divide 10 equal parts. It is a repeating process, and engineers doesn't do the repeating work. He will do the smart work. He doesn't do the hard work. So what we do is, here we divide only the first division. Suppose 0 to 1. This 0 to 1 we divide, and suppose if I want to measure 12.5. So what I do is, from this distance I take the 12. From this distance I'll take the 12 main divisions, and from here I'll take the 0.5. So complete my distance will be 12.5. If I want to measure 10.2, so what I do is, I will highlight 2 mm from this side. I will highlight 2 mm from this side and 10 mm from the other side, so that it will become 10.2. Okay, that is the main use of the plane scale. If you see here, If in this is the plane scale with 1:1 ratio. So suppose if I want to measure 10.2, so what I do is, first one I'll make 0. This is my zeroth division. So if I want to make 10.2, so I will highlight 10 here, and from here I'll mark this is my 1, 2. In the reverse I need to mark, not from here. In the reverse I need to mark 1, 2. So this is my first division, this is my second division. So from here I'll measure the 2 mm, and from here I'll measure my 10 mm. So total become 10.2. Suppose in the same scale, if I want to measure 13.2, so what I do is I will highlight my 13 here. I will highlight my 13 here, and I will highlight my 5 here. This is my 5 mm. So 5 mm plus 13 centimeters, total become 13.5. If in case I want to measure 15 centimeters, maximum distance I want to measure, then what I do is I will highlight the 14 from this side. So this is the 14 centimeters, 0 to 14. I will highlight my 14 centimeters, and here I will highlight my 10 mm. 10 mm equal to 1 centimeter. So this 1 centimeter plus 14 centimeter, total become as 15 centimeters. So that is what we do in the plane scale. Yeah, any doubts you can unmute and you can ask. Anyone, any doubts you can unmute and you can ask. Anyone, any doubts you can unmute and you can ask. So that is the main difference between a normal scale and plane scale. In the normal scale, if I want to make 7.7, then I have to divide 7 and 8 into 10 equal divisions. It is a repeating process. Engineers don't do repeating process. So that's the reason we create a plane scale such a way that first division we make 10 divisions. If I want to measure 7.4, so what I do is I will highlight 7 centimeters from here and 4 centimeters from this side. Then total will become as 4 mm plus 7 centimeters. Total become as 7.4 centimeters. Okay. Any doubts you can unmute and you can ask. Because if you don't understand this, you don't understand the next concept. Okay. Yeah. Anyone, any doubts you can unmute and you can ask. No doubts. Then I'm going to next slide. Yeah. So already we discussed what is a plane scale. It is a consists of 2 subsequent units. Okay. And now we know, now we learn how to draw the construct a plane scale. So there are few steps how to construct a plane scale. The first step is calculate RF. Whether it is 1:1, 1:2, or 2:1, you have to calculate RF. First thing you have to calculate RF. Next thing you have to calculate what is the length of scale. So length of scale equal to RF into maximum distance. If you multiply RF into maximum distance, then you will get LOS. Then you have to find the least count. Least count is nothing but, suppose if you take your normal 15 centimeter scale, the least count is 1 mm, because least count is mm. Least count is 1 mm, because less than 1 mm you can't measure anything on your normal scale. If you want to measure 0.5 mm, it is not possible to measure 0.5 mm on your scale. You can measure only 1 mm. So that is the least count. So what is the least unit you can measure? Suppose in the meter and decimeter, in the if you have created meter and decimeter scale, then decimeter is the least count. If you have created kilometer and hectometer, then hectometer is the least count in that scale. If you have created feet and inches, inches is the least count. Least possible measuring unit is the least count. If you see the millimeter and 1/10th millimeter, then 1/10th millimeter is the least count of that problem. Okay, so like this you have to know, you have to calculate the RF value, you have to calculate the LOS value, and you have to know what is the least count of that problem. You have to know. Okay. Yeah. So I hope you have understood. Before starting the first step, you have to calculate this RF, LOS, and least count. You have to compulsory calculate. And the second step, you have to create a rectangle, because your scale, if you see in your uh, 15 centimeter scale, it is in a rectangle. It is in a rectangle. So compulsory you have to create a rectangle and label the rectangle as A, B, C, and D. Compulsory you have to label it A, B, C, D. Okay. ABCD, and this AB distance, whatever may be the AB distance will be the LOS value. What is the LOS value? This LOS value will be your AB distance. Okay. And height, AD. the AD height you have to take it as 5 mm. In few textbook there are 10 mm you can take, but I suggest students generally take 5 mm because taking 10 mm is no use. So better to take 5 mm. Within 5 mm you can draw, not a problem. Okay, take the height equal to 5 mm. In few textbooks they recommend to take 10 mm. Okay, it's your wish whether to take 5 or 10 mm, but generally I prefer to take 5 mm because if you take 10 mm unnecessarily the sheet will be wasted at the top. Instead of that you can accumulate 2 to 3 problems in one sheet. Okay, so that's the reason I prefer to take 5 mm. You can take 10 mm, it's your wish. Next, what we have to do is, suppose this is 15 centimeters, then what I have to do is I have to divide AB line into 15 centimeters, equal divisions I have to make 15. So then same thing, you have to use the dividing a line. You have to take the inclined line, and this inclined line you have to divide into 15 equal parts. Example, you are creating your same 15 centimeters scale, then you have to divide into 15 centimeters and you have to join and you have to create the 15 centimeters here. Okay, because until and unless you divide equally, because your scale is also 1 to 2 is a equal division, 2 to 3 is a equal division, so that's the reason you have to divide this line into equal number of parts. Okay, and after creating you have to join after dividing this one. So suppose this is your scale. After dividing, draw the vertical lines. You have to draw the vertical lines. Okay, so whatever may be the division, suppose there are 6 divisions, 7 divisions, whatever may be the divisions as per the problem, you have to divide. You have to take an acute angle and you have to incline line and you have to make a divisions. And generally what we do is we mark here as first one as 0, next 1 2 3 4 5, but in this case first one you have to mark it as 0. Why? Because we consider this as our main division, because if we consider other thing, then we have to divide all this 1 to 2, 2 to 3, all divisions we have to make. So instead of repeating the work, what we do is we divide only 0 to 1. So that's the reason here we mark it as 0. Next will be 1 2 3 4 5 6, like that you will get 14 till you get 14. And if you want, total length is 15, total length is 15 centimeters. If you want to measure 15 centimeters, then what you do is you take the 14 centimeter from this side and another 1 centimeter from this side. Total will be 15, but first one we have to mark it as 0. Compulsory you have to mark it as 0. So this is the important point, compulsory mark it as 0 at the first division. Then this will total will become 14. And if I want to measure and I have to divide again, I have to again take my acute angle here. Again I have to take my acute angle and I have to divide this one into 10 equal parts, because I need to know the divisions. So that's the reason I have to make. Then the least count of this one will become 1 mm. Then the least count will become 1 mm. Suppose if I want to measure 10.2, so I will highlight 10 from this side and 2 mm from this side. So total become, this is 2 mm and this is 10 mm it will become. So that's the reason first one you have to mark it as 0. First one you have to mark it as 0, then you are so on, you can mark it continuously. Okay, and at the bottom right corner, and here you have to write the main division. In this scale the main division is centimeters, so you have to write small cm, you have to write. And left side you have to write the subsequent unit. What is the units, how many divisions, what is the single least count you have to write. So here least count is mm, so here you have to write mm, here you have to write cm, and here you have to write LOS or I will show you. Then at the bottom left corner you have to write the subdivision unit. Use the acute angle method and divide it into 10 equal parts and write down the subsequent unit here. Okay, at the bottom center of the rectangle you have to write RF value, because you have calculated RF. No need to show any calculations in the exam. In the exam you no need to show any calculations, just write what is the RF value and just write what is the LOS value. After your calculations, create a rectangle, write what is the RF value you take. Suppose 1.40, 1.1, 1 is to 20, 1 is to 3, whatever may be the whatever may the RF value, you have to write RF value here. In the two horizontal lines you have to write the RF value and LOS value. Here you have to write main division, what is the first main division, what is the subdivision, and what is the RF value, what is the LOS value, you have to mention this one. Okay, yeah, any doubts? Anyone, any doubts, you can unmute and you can ask. Because if you don't understand this, you don't understand other thing. That's the reason I'm explaining slowly so that you can understand. Yeah, any doubts, you can unmute and you can ask. And take the screenshot because it will be helpful while you are drawing on your drawing sheet, because you have to draw it at your home and you have to upload in the Google Classroom. Okay. And those who haven't joined the Google Classroom of EIE, they need to join the Google Classroom and upload your drawing sheet. I'll be correcting your drawing sheet in the Google Classroom. Upload the drawing sheet number 3 in the Google Classroom. Okay. Yeah. So I'm moving to the next slide. Any doubts, you can unmute and you can ask. Anytime you have any doubts, you can unmute and you can ask. So I will show you a small video how to whatever I explained. I'll show you a small video so that you will be understanding what are the things you will be doing. Okay.
Construct a scale of 1:4 to show centimeters and long enough to measure up to 5 decimeters. All right, so two different units have been given to us in this particular problem. One is centimeters and one is decimeter. And you should know this, that 1 decimeter is equivalent to 10 centimeters. All right, so let's move forward. So we have this representative factor, that is 1:4. Or you can also say that the true dimension will be reduced by 4 times. Okay. Now, guys, the scale that we're supposed to prepare should be able to measure up to 5 decimeters. So the maximum length is obviously 5 decimeters. Let's move ahead and let's get the value of length of scale. Now, length of scale is given by this formula, that is RF multiplied by maximum length. So we have RF as 1/4 and we have maximum length as 5 decimeters. So let's just put in all these values and let's see what happens. So we have this length of scale, RF has no units, and this maximum length has a unit, decimeter. So this, if you do this calculation, this is 5, 1 is 5 and divide by 4, it would work out as 1.25 decimeters. But unfortunately, the issue is the scale that we do have is a centimeter scale. The physical scale or a ruler that I'm talking about is something which has dimensions in millimeters or in centimeters. Okay. In India, the most popular scale or ruler is having a dimensional unit as centimeters or in millimeters. Now let's move forward and let's see what else can be done. And hence we need to convert this decimeters into centimeters. Now guys, 1 decimeter is equivalent to 10 centimeter. So the next thing to do is, in place of this decimeter, we'll be writing 10 centimeters. So let's do that. And on doing this calculation, 5, 10, 50 over 4, 50 over 4 is obviously 12.5. That's it. So the length of our scale has worked out as 12.5 centimeters. Okay, job done. Now let's start with the construction. So initially I'll be drawing a line equivalent to 12.5 centimeters, something like this. All right. Now this represents 12.5 centimeter in drawing sheet, but in reality, this represents maximum length. What is the maximum length? It is equivalent to 5 decimeters. So you can also say that the line over here represents a maximum of 5 decimeters. But what to do now, man? As an engineer, we should be able to make sure that this scale is good enough to read up to 1 decimeters. And for that, I'll be dividing this line into 5 equal parts. And for that, I'll be making a line randomly at any angle and of any suitable length, something like this. And then with the radii of 1 centimeter, I'll be putting up arcs. Starting from this point as the center, I'll put up the first arc, and then this as the center, second arc, third, fourth, and this is going to be the fifth arc. Now, the next step is extremely important, guys. You need to make use of a mini drafter. You can keep your mini drafter over here, all right? And then with this point and this point, you need to join these 2 points, okay? That's it. And then tighten the screw, then take your drafter ahead over here, that is at the fourth arc, all right? And then again, you need to draw a line. You can clearly see that these 2 lines are absolutely parallel to each other, okay? And if you keep on moving your drafter to this point, this point, this point, you'll ultimately realize that all the lines drawn are absolutely parallel to each other. And eventually, this dark line that I've made gets divided into 5 equal parts. That's it. Now, in the next step, I'll be giving a height to the scale. Let us say this is going to be 1 centimeters. And let's finish this. Let's start drawing lines from these intersection points like this. All right. So this is basically the skeleton of the scale. And in the next step, I'll be providing designations to all these markings. Okay, guys, let's move ahead. I'll be drawing 4 lines over here. This is the first, second, third, fourth. Now you can clearly see the difference between this line and this line over here. This line appears as if it's very light, and you should use a 4H pencil for doing this. And this line which I have drawn can be drawn with the help of an H pencil. Should be dark. All right. Now, in between these two lines, I'll be placing numbers. Okay. Now, at the end of the first division, I'll be writing a zero over here, something like this. Okay. This is going to be one. This is going to be two, three, and four. Now, each division is equivalent to one decimeter. Okay. So, at the end of first division, if we write place a zero, this is going to be one decimeter, two decimeter, three, four. That's it. Now, to the right of zero, we have the main unit in the form of decimeter, and to the left of zero, we're having the subunit. Okay, and one decimeter is equivalent to 10 centimeters. We all know that. And somewhere over here in between, I'll be writing representative fraction RF that is equivalent to 1 is to 4. That's it. To the right of zero, main unit decimeter, to the left of zero, subunit centimeter. That's it. Now, this portion of the scale over here represents 1 decimeter, and 1 decimeter is equivalent to 10 centimeters. So, in order to see a division of 1 centimeter each, what you need to do is you need to divide this section over here into 10 equal parts. And for that, the process is pretty simple. Okay, and something like this, you have to make arcs over here, 10 arcs. All right, since this has to be divided into 10 equal parts. Now, these arcs that I'm going to draw are of 5 millimeters. You can always change the arc radii. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. Now let's join this point with this point. Okay, since this much is the portion that we need to divide into 10 equal parts. Let's do that. Now you can keep your trapezoid over here. Okay, tighten the screw, move it to the ninth point, and then draw a line. You can clearly see that these two lines are absolutely parallel to each other. Keep on doing so from the eighth point, 7, 6, 5, 4, 3, 2, 1. That's it. You can clearly see that this line gets divided into 10 equal parts. All right. In the next step, I'll be shifting these points somewhere here. This line that I've drawn is at a height of 5 millimeters, say, and I have to shift this point over here and draw a line. Then this point, draw a line. Something like this, and please watch it carefully. You can keep your drafters absolutely set and bring it over this first point, say, and then you need to draw a line, something like this. Then shift your drafters slightly ahead towards this point and then draw a line yet again. Now keep on repeating this process until you have all these 10 markings. All right. So this over here, this small portion over here, guys, represents 1 centimeter. This portion over here represents 2 centimeter. If you keep on going here, you'll see this much distance represents 5, and this much.
Okay. So what we have to do is first we have to make the main divisions based on LOS. This is the length of LOS. We have to make the total 5 divisions. In the problem they have asked total 5 units of decimeter. So we will be dividing 5, and this 5 first we'll mark it as 0, 0 and 4. This is a 1, 2, 3, 4, and if you add this one it will become 1. Okay, and you have to again divide this main unit. First main unit you have to divide into 10 equal parts because 1 decimeter equal to 10 centimeters. So that's the reason we'll be making this 1 decimeter equal to 10 centimeters. So that's the reason this is a 1 decimeter line. So for this 1 decimeter line we have to divide into 10 equal parts, and this height will be 5 mm, and we'll be dividing 10 equal parts. And if you want to measure, suppose 3.2, 3 decimeter and 2 centimeters. So what I have to do is I have to highlight 3 from this side. I have to highlight 3 from this side, and I need to highlight 2 from this side. So total will become 3.2 decimeter. Suppose if I want to highlight 2.8 decimeters, then what I do is I will highlight 2 from this side, and I will highlight 8. This is 10, 9 and 8. So I will highlight the 8th point. This will be 8 centimeter, and this will be 2 decimeter dm. Okay, so total become 2.8 decimeter. Okay, so like that you have to make the division. Any doubts you can unmute and you can ask. I'll also share this video in the in our Google Classroom. I'll share the video. Any doubts you can unmute and